So the project that we are going to discuss today is the automated hearing aids. Okay, and we had designed this project using hardware. We had not used any software part. Okay, uh, we had just used hardware. So yeah, we'll just look at the block diagram first. Uh, so this is the block diagram of our project. Like obviously when a sound signal or a sound energy is coming, and when it hits the mic converts that sound energy into electrical impulse or into electrical energy. Then this is given to preamplifier and comparator and controller, and from controller it is given to amplifier. And here, from here, this from transducer it is given the electrical impulse is also fed to the buffer amplifier and again to the amplifier and speaker at the output. So I will explain each and every block, okay, that how it works and what significance it has. Okay, so first talking about mic. Okay, I would also like to show you the circuit diagram. The values of the circuit diagram are not given here. You will get all the values of the circuit diagram and all in our post which I had uh, shared in the description box. So please do visit there and just read that post. You will enjoy reading it and you will also understand this concept. Okay, so without wasting on time, I'm starting with this circuit diagram. Like this is the mic which you are seeing over here, 1 and 2 and C1. Okay, um, so I will just explain you some things or some information about mic. Obviously you will know it, but still from my side I'm doing it. Okay, so this is our mic. Okay, and obviously we all know that this sound energy is like compression, ray refraction, again compression and ray refraction and all. Okay, that means I can also draw the signal like this. uh, Compression, ray refraction, compression, ray refraction. So this part with higher amplitude, it represents compression. This part with lower amplitude, it represents an ray refraction. Okay, and then depending on this signal, okay, depending on this signal, the output of mic would produce some analog form or some electrical impulse. Okay, so this is only about mic. And another thing I would like to specify over here is that the mic that we are using is an electret condenser mic. Okay, it is an electret condenser mic, and its sensitivity is around 6 millivolt per pascal to 18 millivolt per pascal. Okay, so this was about the mic. Okay, now we will further discuss the block diagram and again circuit diagram. uh, as you can see over here that it is a preamplifier. From the transducer or from the mic, the output of mic is fed to the preamplifier and buffer amplifier as well, but we will discuss this the lower part of the block diagram later on. First we'll look the upper part, because this preamplifier, comparator and controller forms the heart of our project, and the lower part is like a brain of our project. Okay, so we'll discuss with preamplifier first. And over here, okay, so here just a second, size. Okay, so this part, okay, so this part is a preamplifier part. Okay, this first transistor which you are seeing over here, this is a preamplifier part. And okay, so this is a preamplifier, and preamplifier is nothing but an amplifier. Okay, so this is few millivolts of signal and you are amplifying it to some voltage signal. Okay, this may be in few millivolts and you are amplifying it to volts. This is the basic task of preamplifier. Okay, and I had designed this preamplifier in such a way that if this signal is greater than equals to 10 millivolts, then at the output I will get 3 volts of signal. Okay, so this is how a preamplifier will work. Okay, this was about the preamplifier. Now we will so the next component or the next block in a block diagram is this comparator. Okay, and obviously a comparator is made up of IC741, that is a op-amp. And yeah, uh, mm, so this is a comparator. Okay, and this is a variable resistor. I will explain you, but before that I will explain some part of comparator, that like how it works and all. So basically this is your op-amp. Okay, this is its Vout terminal. This is pin number 3 positive and this is pin number 2 negative, and from here it is plus VCC, and here you are connecting minus VCC or VEE. Okay, so now let's say you are applying 2 volts of signal at positive pin, that is pin number 3, and 0 volt at negative pin. So at the output you will get plus VCC. This would be reflected at the output plus VCC. Okay, now just think that you are giving plus 2 volts of signal at the pin number 2 and 0 volts to pin number 3. So at the output you will get this minus VCC. This minus VCC would be reflected at the output. Okay, that let's say if it is V1 and if it is V2. So I'll use some different color so that you would grab it easily. So if V1 is greater than V2, so at the output you would get plus VCC. Okay, and if V2 is greater than V1, so at the output you would get minus VCC. So this was the basic working of the op-amp. Okay, you can also call this plus VCC as logic 1 and this as logic 0. So I hope you understood this concept. Okay, now we will discuss about the variable resistor. So what is variable resistor? This is a resistor, okay, and you are showing an arrow. So this, what does this mean? It means that I hope you had I hope you had seen this kind of circuit. Okay, and I hope you also know this. It is a voltage divider circuit. Okay, this means that if your variable resistor is of 200 ohms, it is of 100 ohms. It may be of 50 ohms and it may be of 150 ohms. The lower end it depends, but for now I am taking 100 and 100 ohms. And this is a Vout. Okay, but this arrow means that you can rotate it up or you can rotate it down. That means if you're moving it down, then the resistor of this resistor, okay, will decrease, and if you are moving it up, then the resistance of this resistor will decrease. Okay, I will explain you again. Use some different color. Let's say this is your variable resistor, and if the arrow is down, okay, this means, for example, just now I'm taking again 200 ohms. This means the resistance of the above resistor is 100 ohms and the lower one is 0 ohms, and this is your Vout. So basically, and in our case it is connected to VCC plus, that is a 5 volt. So obviously current will move here, and obviously it is 0 resistance over here, and it is high resistance over here at the P out. So basically the current will move down and the output you will get 0 when this arrow is representing down, like resistor, and the arrow is somewhere around over here, not down. Okay, now let's say again this is a variable resistance, and over here the arrow is up above the variable resistor. This means that this is a voltage divider circuit. You are giving 100 ohms, and this means that here it is 0 ohms. This is your Vout. It won't be there won't be any 0 resistance as such, like you are decreasing or increasing, but For now I'm considering this 0 ohms. This is your output. Okay, so now uh, your current will move in this direction. Now it will see that output has less resistance than this one. Okay, so the current will move in this direction, so your output would be high in this case. Okay, so this was the basic idea about the variable resistor. I hope you understood it. Okay, now the next block of the block diagram is controller or timer circuit or IC555 circuit. Okay, so in our circuit diagram it looks like this. mm, yeah, so this whole thing is an see, this whole part is our IC555. Okay, so I will explain you how it works in short, not fully, if you are new to it. If you are if you know that what IC555 is, then it's really good, you can understand it very easily. But for those who are new and who really don't know what is IC555, so before that I would like to explain this concept of NOT gate. I hope everyone knows it. Like if you are giving logic 1 at the input, then at the output you will get logic 0. Okay, similarly if you are giving logic 0 at the input of NOT gate, you will get logic 1 at the output. Okay, so this was a basic thing about NOT gate, but not talking about any triple five. So our any triple five also works in the similar way. This is a triple five circuit. Pin number 2 you will get some logic 1, and the pin number 3 you will get logic 0. Okay, again if you are giving 0, you will get logic 1 at pin number 3. But here there is something to do which we are using triple five circuit. There is some what you say suspense like thing to which I'm using triple five circuit. Okay, and the suspense is nothing but the time. Okay, time period in that NOT gate. Okay, let's say if you are giving this kind of signal, you are getting this kind of signal at the output. Like the signal is same, but just the thing is that it is inverted. Okay, but in case of any triple five, let's say if you are giving a random signal like uh, any thing anything like this, you can set your output according to your desire. Okay, obviously the output get triggered this negative when it encountered this negative or zero logic, but you can set your output accordingly. Okay, let's say in our case, let's say this is triple five circuit. Okay, and pin number 2, and this is pin number 3. This is pin number 2. Remember one thing, when you get very such kind of signal, like if the signal is continuous, positive negative, okay, negative triggering edges, you are getting like this continuously. So at the output you will get pure DC or logic 1 for high amount of time. Okay, for high amount of time. Since our signal is analog, so obviously we will be getting such kind of signal. That's why our output would be logic 1 for high amount of time. Time period would be high, or sorry, our time period would be high. Okay, and we had set our time period which is of 1 second. Okay, so that means even if you are getting, let's say, any signal for few microseconds, then also at the output will get this logic 1 for 1 second. Okay, so we had set this whole we had considered this thing, and we had designed the circuit accordingly.